Out beyond the warmth of any human world, in the deep black, where sunlight thins to a ghost, something impossible happens. A single traveler drifts through that void, its nucleus locked in ancient ice, its orbit stretched into infinity. Yet against every law of thermodynamics it exhales. Vapor streams from its surface like the slow breath of a sleeping giant. Astronomers name it 3E Atlas, a wanderer from another star, but that name cannot contain what it's doing. It is breathing in a place where breath should freeze solid. No comet from our system behaves this way. Beyond the orbit of Mars, most of them fall silent, their ice is sealed tight by cold. But this one releases 40 kilograms of water every second, a steady pulse of vapor bursting into a coma so wide it shrouds the nucleus like a living aura. To the telescopes turned its way, that halo gleams faintly blue, a whisper of ultraviolet light that betrays molecules being torn apart. Water dying in sunlight, and in that death announcing that water lives there at all. When astronomers first noticed it, they hesitated to believe. The data came from SWIFT, a space telescope built to hunt gamma-ray bursts, not comets. Its sensors recorded hydroxyl molecules tracers left when sunlight rips hydrogen from oxygen, too many to dismiss. The readings implied torrents of sublimation far beyond anything seen so far from the Sunday. At 3.5 astronomical units, where solar heat should be weak as candlelight, 3 Atlas was behaving like a comet already in the inner solar system. Something inside it was awake. The mystery spread across observatories like wildfire. Radio astronomers checked the numbers. Optical telescopes confirmed the glow. The figures refused to change. For a moment, the scientific community shared a collective chill. Had they just seen an object acting alive? The phrase wasn't meant literally, but it felt that way. Something about the rhythm of the outgassing, the steadiness, the pulse, the almost biological cadence made the comparison irresistible. Imagine drifting there beside it, suspended in silence. You'd see jets of vapor streaming from fissures that crack open and seal again, flashes of crystalline dust sparkling in sunlight older than our species. Every burst expands into the vacuum, freezing almost instantly, a shimmer of diamond-bright motes that spread until they vanish. Each jet marks another heartbeat of this strange traveler, each plume another breath drawn from stone. News outlets rushed to frame it in human terms, the comet that breathes. They called it a headline too poetic to resist. You could almost hear the marketing hum of wonder, but beneath it lay genuine astonishment. Veteran comet researchers confessed they'd never seen anything like it. The math said it shouldn't happen, the instruments said it was. The paradox was absolute. There are moments in science when data humbles certainty, when nature presents a phenomenon so brazenly outside expectation that disbelief gives way to reverence. This was one of those moments. In the cold nowhere between planets, a relic from another sun was performing a kind of resurrection matter, long frozen finding motion again, as if memory itself were thawing. As observatories kept watching, the questions multiplied faster than the answers. Was the comet rotating, oddly focusing faint sunlight onto hidden reservoirs of ice? Did it contain exotic compounds that turned solid to vapor at lower temperatures than water? Could radioactive decay within its core still be generating heat, billions of years after formation? Or was there some deeper chemistry, a reaction that belonged to another star's recipe? Each possibility felt like a clue torn from the edge of understanding. Astronomers began to treat 3 Atlas not as an anomaly to be explained away, but as a messenger, a signal from a set of cosmic rules we hadn't met yet. In its shimmering coma, they glimpsed not just physics but history, the fingerprints of a stellar nursery older and stranger than our own. And somewhere inside that halo, locked beneath layers of ice older than Earth, lies the story of its home system, the temperature, the radiation, the balance of metals and gases that once circled another Sunday. Every molecule drifting away from 3 Atlas is a syllable of that story written in vapor and light, disappearing as soon as we read it. If this story made you pause for a moment, if it reminded you that the universe still breathes in silence, then take a second to support our journey through the stars. Give this video a like, subscribe to the channel for more stories where science meets wonder, and share in the comments what moment in space has ever made you stop and feel small. Every click helps this tiny channel reach further into the dark, chasing the next story waiting to be told. This has been The Comet That Breathes. Stay curious, stay kind, and keep looking up, because out there the universe is still writing. If you could stand on its surface, you'd hear nothing. The vacuum steals all sound, but you might feel vibration through your boots, the faint tremor of escaping gas, like a slow exhale echoing through the rock. Out there, breath is impossible, yet this comet finds a way. It is a contradiction shaped by physics and distance, and it makes the universe feel briefly alive. The signal first appeared as a shimmer on a graph, numbers trembling at the edge of certainty, ultraviolet photons where none should exist. The Swift Space Telescope, an instrument built to chase the explosions of dying stars, found itself staring at something far quieter, yet infinitely stranger. A comet releasing light in wavelengths that only one process could explain. Something was tearing water apart in the dark. Hydroxyl radicals, abbreviated OH, were dancing through the void around 3 Atlas. Each one was a ghost of a murdered water molecule, born when sunlight shattered H2O into its elemental fragments. On Earth, this process happens in laboratories or upper atmospheres. Out there, it should have been impossible. The comet was more than 3 times farther from the sun than our own planet, bathing in weak light that could barely warm an airless rock. Yet Swift's ultraviolet spectrometer told an unambiguous story. Oceans of vapor were being ripped into mist. Astronomers triple-checked the data, recalibrated instruments, hunted for errors. None emerged. The readings persisted. The rate of water loss translated to more than 40 kilograms per second, enough to fill a bathtub every heartbeat. At that distance, a normal comet would be inert, frozen beneath layers of dust so cold that not even carbon monoxide could easily escape. 3E Atlas ignored the script. To visualize it, picture the comet's nucleus, a mountain of ice and rock about the size of a small city slowly rotating in the black. Around it swirls a vast sphere of vapor and dust, glowing faintly in ultraviolet. Each atom within that cloud tells a story of violence. Sunlight striking a molecule, ripping electrons free, transforming frozen water into an invisible cry of light. Swift's detectors, tuned to the edge of the spectrum, captured that cry, converting it into digital echoes that traveled across space to our antennas on Earth. When the data reached mission control, there was confusion before awe. Astronomers aren't quick to declare miracles. They look for leaks, for miscalibrations, for cosmic rays sneaking into detectors. But as the hours passed, more instruments confirmed the finding. Other observatories joined the watch, ground-based telescopes in Chile and Hawaii, in the Canary Islands, each catching the same spectral fingerprints. The comet was venting water at a rate no model could justify. Imagine the shock in those late-night control rooms, teams of scientists staring at readouts that contradicted everything they'd been taught. For decades, cometary behavior was predictable, quiet when far from the sun, loud only when nearing it. The equations were solid, the physics straightforward. But the universe, as it so often does, had decided to play jazz. 3 Atlas was improvising in a key no one had heard before. News of the anomaly leaked quickly into academic networks, then to the public. Social media lit up with the term breathing comet. Amateur astronomers posted long exposure photos showing a faint blue aura, expanding night by night. The phrase took hold not because it was accurate, but because it captured something visceral, the idea of life where none should be. In the glow of the comet's coma, people saw a metaphor for persistence for the universe, refusing to be as simple as we'd written it. But inside observatories, the mood was sharper, hungrier. Questions multiplied. Was the activity driven by internal heat, left over from the comet's formation? Could radioactive isotopes buried in its core be thawing the surrounding ice? Or did the object contain exotic materials, supervolatile ices that vaporized at temperatures far below waters? Each hypothesis demanded new simulations, new models, new sleepless nights. Swift kept watching. The ultraviolet emissions fluctuated, rising and falling in rhythm with the comet's rotation, as though the nucleus were turning toward and away from the sun, exposing active regions like breathing lungs. When astronomers plotted those cycles, a faint periodicity emerged. Every few hours, the light curved upward again. The comet wasn't just venting randomly, it seemed to have a pulse. In press briefings, scientists avoided the metaphor, but they couldn't avoid the emotion behind it. For the first time in memory, a comet had become a protagonist, a character in a story that blended cosmic physics with existential wonder. Beneath its cold surface, something alien was unfolding, a process that belonged to another star's chemistry and was now playing out under our gaze. Swift's ultraviolet echo was more than data. It was a whisper from an ancient traveler, and the universe clearing its throat to remind us how little we understand. Every photon captured by the telescope was a syllable in a message, billions of years old, traveling across darkness until it struck a mirror, a sensor, a human mind ready to ask why. Every measurement screamed contradiction. The math said a comet that far from the sun should be a frozen relic, a silent monument to deep space cold. Yet 3 Atlas was boiling at a distance where heat was a rumor. To understand how astronomers did what they always do when nature misbehaves, they built hypotheses as fast as they could think. First came the old explanation, solar heating. Maybe the comet's rotation exposed small patches of volatile ice, hidden reservoirs that caught sunlight just long enough to erupt. But that theory crumbled under the numbers. At 3.5 astronomical units, solar energy falls to 1/10 of what Earth receives. Even if every photon struck perfectly, it couldn't melt enough ice to create the furious plume Swift saw. The physics didn't balance. So they searched deeper. What if 3 Atlas carried exotic ice's substances so volatile that they vaporized in mild warmth? Some suggested carbon monoxide or carbon dioxide ices close to the surface, each with lower sublimation points than water. But even those couldn't explain 40 kilograms per second. Others reached for chemistry itself. Maybe internal reactions, exothermic processes between trapped gases and minerals were generating the heat from within. A chemical heartbeat pulsing through the rock. And then came the stranger ideas. Could residual heat from its birth locked within its nucleus for billions of years still be radiating outward? Could radioactive decay of isotopes like aluminum-26 or iron-60 be providing a steady, invisible warmth? Those isotopes decay over millions of years, yet perhaps 3 Atlas formed with unusual concentrations, giving it a faint but persistent ember at its core. It was speculation bordering on science fiction, yet the comet's behavior forced scientists to consider it. In the meantime, every telescope that could turn toward the object did. Optical observatories charted its rotation rate slower than expected, as if dragging an invisible weight. Spectrometers picked apart the composition of its coma water, carbon dioxide, cyanide, and something else they couldn't quite classify. Instruments whispered of compounds unknown, molecular signatures that didn't match any terrestrial database. The idea began to spread that this comet might not just be foreign, it might belong to a chemistry set older than our Sunday. Within labs and conference rooms, whiteboards filled with scrawled equations, thermal models were run and rerun. None could reproduce the data. The only thing that made sense was that something wasn't supposed to make sense. When a natural system breaks your predictions, it's telling you your understanding is too small. That realization rippled quietly through the community. The mystery of 3 Atlas wasn't an error, it was an invitation. In coffee-fueled meetings, astronomers argued over energy balances and spectral line intensities. One pointed to rotational asymmetry. If the comet's spin axis were tilted, sunlight might strike deep fissures at just the right angles to ignite runaway sublimation. Another proposed subsurface pockets of gas under pressure sealed for eons, and now erupting like geysers as tiny impacts or thermal cracks opened vents. The term vent cascade entered the notes describing how one outburst could trigger another, a chain reaction of escaping volatiles. And then came the uncomfortable question no one wanted to say out loud: what if we're seeing a process entirely alien to our solar chemistry? Not alien in the science fiction sense, but literally foreign-born in a stellar nursery where different ratios of elements created unfamiliar physics. If 3 Atlas was forged around a star with more nickel, more carbon, or less oxygen, its ices might behave in ways we've never observed. Its heat capacity, reflectivity, and internal structure could all be off script. That thought lingered longer than most hypotheses. It reframed the mystery from how can it breathe to what does its breathing tell us about its birthplace. Every molecule escaping the comet carried a chemical fingerprint, an isotope ratio carved by the environment that birthed it. In those ratios, hidden in the light, were stories of stars that lived and died long before ours. As the data poured in, an image formed of a body both fragile and fierce, a relic that refused to die quietly. Its jets carved spirals through the coma patterns so consistent they hinted at internal order. Computer models translated those plumes into simulated 3D flows, revealing something mesmerizing. The ejected gases created their own microclimate, a thin envelope of warmth recycling back toward the surface, sustaining further sublimation, a self-feeding system. Not alive, but behaving as if it understood survival. In those days, every update from 3 Atlas felt like a cliffhanger. Journalists used words like defiance, resurrection, alien logic. Scientists used words like outlier and nonlinear dynamics, but their voices betrayed the same awe. The comet had become a mirror, reflecting our oldest instinct to find life, even in lifelessness. If nature can breathe without lungs, glow without heat, and move without motive, what else can it do that we haven't yet imagined? The impossible equation remained unsolved, but for the first time in years, astronomers found joy in not knowing. Mystery had returned to the night sky, bright and cold and gloriously alive. Before 3 Atlas arrived, humanity had already met 2 wanderers from the stars. Each one rewrote a line of cosmic history, a prelude to the enigma now streaming through our solar system. Their names, Oumuamua and Borisov, still echo in the halls of observatories, whispered as benchmarks of what alien really means in the language of celestial mechanics. The first visitor, Oumuamua, was discovered in 2017 by the Pan-STARRS telescope in Hawaii. At first, astronomers mistook it for another asteroid, but its path through space betrayed something extraordinary. It wasn't looping back like comets and asteroids born of our sun. It was on a hyperbolic trajectory, slicing through the solar system and back out into interstellar space. Unbound, a message written in motion, I came from elsewhere. Unlike 3 Atlas, Oumuamua was silent. It carried no tail, no shimmer of outgassing, no halo of light. Just a sliver of rock tumbling end over end, reflecting sunlight in uneven flashes that made it seem to flicker. Its shape, thin, elongated, perhaps cigar-like or pancake flat, defied easy categorization. And yet, something about its path refused to obey gravity alone. It accelerated ever so slightly, as though pushed by a whisper of force unseen. The explanations ranged from the sensible to the fantastical. Some argued that radiation pressure from sunlight bouncing off a low-density surface could account for the anomaly. Others speculated about hydrogen ice sublimating and visibly producing thrust too faint to detect. But for a time, a bold hypothesis emerged. What if it wasn't natural at all? A light sail, some said, a relic of an alien technology drifting between stars. The claim lit the internet on fire. Scientists debated, skeptics countered, but the seed was planted. Not everything wandering through space plays by known rules. Then came Borisov in 2019, the second confirmed interstellar visitor, and the first that felt familiar. It looked and acted like a comet, a nucleus of ice, a tale of dust chemistry that fit the textbook, a cosmic reassurance that the universe, while strange, still had some consistency. But even Borisov carried its oddities, unusually high levels of carbon monoxide, a composition hinting that it formed in a colder, more distant region than most comets in our solar system. It was alien, but in a way we could understand. Now, with 3 Atlas, the narrative had shifted again. Where Oumuamua was too quiet and Borisov too conventional, Atlas stood defiantly in the middle, loud where silence should reign, wild where order should persist. It wasn't just passing through, it was performing. Every puff of vapor was a declaration, I am not like them. For scientists, comparing the 3 became irresistible. Each represented a point in a cosmic spectrum, the dry enigma, the predictable wanderer, and now the impossible breather. Together they formed a pattern, a glimpse into the staggering diversity of worlds orbiting distant stars. If 3 random interstellar visitors were this different, how many kinds of planetary systems must exist across the galaxy? Theories bloomed like constellations. Maybe Oumuamua came from a rocky inner system stripped of volatiles by a long-dead star. Perhaps Borisov formed beyond a distant snow line rich in carbon monoxide and dust. And maybe 3 Atlas was born in a nursery drenched in elements we barely recognize, an ancient stellar neighborhood where nickel flowed freely and ice chemistry took alien forms. Each traveler carried its home in its atoms, a portable sample of its parent star's personality. Astronomers began to see these interstellar visitors not as curiosities but as evidence proof that our solar system is not unique. Every arrival was a data point in a grander map of galactic formation. The realization was humbling. We were not studying outliers, we were glimpsing the norm of everywhere else. But with 3E Atlas, humility deepened into unease. The comet's water production, its defiant chemistry, its eerie glow, they all whispered that even natural might have broader definitions than we imagined. It was behaving like an organism without being alive, adapting to conditions no model could predict. It blurred boundaries between the physical and the metaphorical. Scientists found themselves using words like awake and alive in technical papers as if ordinary language had failed them. To a watching public, those words were magic. Alive meant wonder, breathing meant mystery. The comet became a cultural event, a celestial protagonist with more charisma than some movie stars. It trended across platforms not as a dry data set, but as a living symbol of curiosity itself. For a moment, astronomy and storytelling fused. The mystery of 3 Atlas reminded humanity that science at its best is poetry written in numbers. And in that poetry, a new verse was forming. If the first visitor showed us how quiet interstellar space could be, and the second reminded us of home, then the third had come to tell us that the universe still holds secrets loud enough to shake certainty. Somewhere beyond Pluto's orbit, the comet continued its impossible exhalation. It glittered against the dark, a spark of motion carrying whispers of other suns. For every scientist peering through a telescope that night, one question burned brighter than all others. What kind of place makes comets like this? Out beyond the orbits of the outer planets, 3 Atlas drifted through sunlight so weak it could not melt frost on glass. Yet something inside that comet was rewriting chemistry. The data arriving from telescopes around the world spoke of molecules arranged in ways that did not belong to our neighborhood of stars. Every comet we know follows the same general playbook. When it approaches the sun, its surface warms, ices turn directly into vapor, and streams of dust create a tail. The ratios of gases, water, carbon dioxide, methane are familiar and predictable, but 3 Atlas threw those ratios into chaos. Its emissions were dominated by carbon dioxide with water as the secondary player. Cyanide and nickel shone in the spectra where they had no business appearing. It was like hearing a familiar song played in an alien key. Scientists called it chemical inversion. In our solar system, comets form where water ice condenses easily, while carbon dioxide, more volatile, tends to hide deeper within. But here everything was backward. The carbon dioxide came first, the water followed. If that wasn't strange enough, trace elements hinted at a lack of iron and an overabundance of nickel. That imbalance didn't just raise eyebrows, it broke the rules of planetary formation as we understood them. So, they asked the only logical question: what if the rules were different where this comet was born? The composition of a star determines what its planets and comets can be made of. A sun richer in certain elements can create worlds with entirely new chemistries. Maybe the star that birthed 3 Atlas had a skewed recipe, a cosmic kitchen using ingredients unavailable here. Imagine a stellar nursery billions of years ago, lit by stars more massive than ours, their explosions seeding clouds of gas with heavy metals in strange proportions. Within those clouds, dust grains condensed and collided, forming icy bodies with unconventional blends of elements. Nickel bonded with carbon to create volatile compounds that evaporated at the gentlest touch of light. Iron, less common in that environment, became a rarity. When such a comet formed, it would naturally behave differently under heat-emitting nickel vapor long before any iron appeared. To trace that ancestry, astronomers compared the spectral fingerprints of 3E Atlas with data from nearby stars catalogued by the Gaia mission. They found subtle echo signatures that resembled older stellar populations, known as the thick disk, a region of our galaxy populated by ancient suns. Those stars were born before heavy metals had spread evenly across the Milky Way. Their children would be chemically odd, forged in scarcity and imbalance. That idea electrified the research community. If 3E Atlas came from that population, then it might predate our Sun by billions of years. Every molecule escaping its surface would be a relic of a time when the periodic table itself was still being written by supernovas. Its chemistry wasn't just foreign, it was primordial. Think of it as a fossil, but not of bones or shells. A fossil made of ice and rock, carrying the fingerprints of stellar generations long extinct. By studying its emissions, scientists were essentially performing cosmic archaeology, reading history written in atoms. Each ratio of nickel to carbon, each absence of iron, each burst of cyanide told a story of different physics, different temperatures, different kinds of starlight. What made the discovery profound wasn't only the anomaly, it was what it implied about the universe. If 3 Atlas obeyed laws written in another star's chemistry, then every planetary system out there might have its own version of normal. Our definition of standard might be local, not universal. What we call impossible could simply be uncommon. Under that realization, even the strangest data began to make sense. The comet's wild activity at great distance, its green glow, its reversed gas hierarchy, they were all symptoms of a body made by rules that belonged to someone else's star. We weren't witnessing defiance, we were witnessing difference. And so, astronomers began to look at 3 Atlas not as a rebel, but as a teacher. It was showing us that nature's diversity extends far beyond imagination, that the chemistry of life and matter itself is richer than any earthbound textbook. Its behavior was not breaking physics. It was expanding it. Somewhere inside that nucleus, in chambers of ice untouched for billions of years, lie the secrets of that long-vanished world. When sunlight strikes it now, those secrets evaporate molecule by molecule, drifting into the void, crossing light years to meet our instruments. In every photon that reaches us is a whisper from another era. The rules you know are not the only ones. Among the strangest revelations from 3 Atlas was a metallic riddle so profound that even seasoned astronomers fell silent before it. Nickel without iron. In the universe as we know it, those two metals are inseparable companions, born together in the fiery hearts of dying stars and scattered by supernovae into the dust that builds planets and comets. Wherever there is nickel, there is iron, always without exception. Until now. When the Very Large Telescope in Chile turned its gaze toward 3 Atlas, its spectrograph caught a light unlike any other. The emission lines glowed green and gold, sharp and pure, corresponding precisely to vaporized nickel atoms. But when the scientists searched for iron's telltale fingerprints, those thin, dark lines that should have appeared beside nickel, they found nothing. Silence. The ratio wasn't just skewed, it was inverted. Nickel was singing solo. At first, the data looked like an instrument error. The team recalibrated, cleaned the optics, and observed again over several nights. The same signature appeared every time: bright nickel, faint or absent iron. The results were sent to other observatories for confirmation. Within weeks, telescopes in both hemispheres had verified the impossible. The comet was exhaling pure nickel gas gram after gram every second, as if iron had been erased from its birth equation. To grasp how strange that is, imagine a fire that produces smoke but no heat, or a voice with no echo. In our solar system, when comets approach the sun and metals begin to sublimate, iron and nickel emerge together, locked within the same mineral lattices. They form side by side inside the metallic grains that cooled in the early solar nebula. Their physical properties, boiling points, vapor pressures, are so similar that separating them naturally is nearly impossible. Yet 3 Atlas had done exactly that. So what could have caused it? One idea pointed to chemical fractionation during formation. Perhaps in the star system where the comet was born, the environment favored nickel-rich molecules that evaporated easily, while iron condensed into heavier compounds that never made it into the icy mix. Another theory involved organometallic chemistry, nickel atoms bound to carbon monoxide in fragile molecules that vaporize in gentle heat. When sunlight hit those compounds, they would break apart, releasing free nickel atoms into the coma, while the iron remained trapped in the nucleus. There was also space weathering, the cosmic sculptor that works over eons. Interstellar radiation can strip surfaces, rearrange atoms, and change chemical bonds. Maybe during its long journey through the void, 3 Atlas had, its outer layers transmuted iron, buried or altered, while nickel rose to the surface like a ghost of ancient chemistry. But the boldest speculation reached beyond chemistry into astrophysics. Nickel and iron form in different proportions depending on what kind of supernova created them. Some explosions, particularly those from white dwarf stars collapsing under their own weight, favor nickel production. Others, like core collapse supernova, yield more iron. If 3 Atlas was assembled from dust left behind by an unusual type of stellar death, its abnormal metal balance might be a fingerprint of that origin. A relic of a single long-vanished star's final breath. To scientists, that possibility was intoxicating. It meant that 3 Atlas might be carrying the ashes of a specific event from billions of years ago, a chemical echo of a single detonation written into its structure. By studying its light, we weren't just learning about a comet. We were peering into the life story of a star that exploded before Earth existed. Yet the human mind cannot resist the symbolic. Nickel without iron became more than a chemical anomaly. It became metaphor. People began calling it the metal ghost, a poetic reflection of how something could exist where its partner had vanished. Artists painted the comet as a silver-green spectre. Commentators spoke of a universe rewriting its own chemistry before our eyes. For astronomers, however, the wonder came with discipline. They rechecked spectra at different solar distances, hoping to see iron emerge as the comet heated. None did. The anomaly held steady, defying both skepticism and expectation. The deeper truth was simple but profound. 3 Atlas had been forged by a rulebook not written in this corner of the cosmos. In the faint light reflected off its metallic coma, we could almost read that rulebook's title, "Diversity is the Law." For the first time, the cosmos was reminding us that even the most elemental pairs, nickel and iron, birth and death, question and answer, can be torn apart by distance, by time, or by the will of a different star. The discovery of nickel without iron hit the astronomy community like a thunderclap. For generations, scientists had treated the pairing of those two metals as a constant of the universe, a quiet assumption beneath equations and models. Now that assumption lay in ruins. Across research centers from Geneva to Pasadena, whiteboards filled overnight. Equations half erased and rewritten sprawled across walls like frantic constellations of chalk. At the European Southern Observatory, a young spectroscopist leaned over her terminal and muttered the phrase that would echo through every news headline the next day. "It's like finding smoke without fire." She wasn't exaggerating. To her, the data from 3 Atlas wasn't merely strange, it was heresy. The first wave of explanations emerged quickly. Some theorized that nickel atoms in the comet were locked into fragile carbon-based molecules, nickel carbonyls, that vaporized far more easily than solid metals. On Earth, such compounds are known to chemists. They form in industrial processes, shimmering as metallic gas under specific conditions. If the environment where 3 Atlas formed had been rich in carbon monoxide and organic radicals, then nickel could have hitched a molecular ride into volatility, leaving iron behind. Other researchers turned to temperature thresholds. Nickel's sublimation point, they reminded everyone, is only slightly lower than iron's, but in a low-pressure environment, small differences can matter. Perhaps microstructural quirks, tiny pockets of porous ice, created heat traps selectively releasing nickel while keeping iron bound. Each hypothesis felt like a patch on a balloon full of mystery. None explained why the phenomenon was so clean, so consistent, so deliberate. And then the truly radical ideas began to circulate. A paper out of Kyoto suggested that 3 Atlas might have formed in a protoplanetary disk irradiated by a nearby supernova. That intense radiation could have altered isotopic abundances, locking iron into stable oxides while leaving nickel more reactive. Another group proposed a phenomenon they called cosmic distillation, a process where electromagnetic fields in the young disk segregated elements by charge, sifting them like sand in a magnetic tide. To some it sounded poetic, to others madness. Meanwhile, astronomers studying the comet's green glow noted that the nickel emissions weren't random flickers, but followed a rhythmic pulse. The pattern matched the comet's rotation, suggesting that the metallic vapor escaped from fixed vents on its surface. Those vents, perhaps remnants of ancient fractures, might expose reservoirs of volatile compounds untouched since the birth of the galaxy. Every time sunlight grazed those regions, they exhaled. In late-night calls between observatories, a strange mix of excitement and dread took hold. The more they learned, the less the universe looked familiar. A senior astrophysicist summarized it bluntly. If this is real, then chemistry isn't universal, it's provincial. The words felt almost blasphemous, but the comet refused to behave otherwise. Public fascination followed close behind. News outlets dubbed 3A Atlas the alchemist's comet, claiming it turned invisible elements into light. Social media, filled with animations of glowing green plumes, each one captioned with wild theories, alien mining, cosmic engines, even interstellar messages encoded in nickel flashes. Scientists sighed, but secretly many shared that same awe. How could you not when staring at something that made the universe feel vast again? Inside the laboratories, though, wonder was tempered with method. Samples from simulated cometary material were heated in vacuum chambers, bombarded with ultraviolet light, blasted with cosmic ray analogues. The goal was simple: recreate the nickel emission without iron. Most experiments failed spectacularly. The ones that came close did so only under bizarre conditions, mixtures rich in carbon monoxide temperatures, colder than nitrogen's freeze point, and magnetic fields that mimicked those around dying stars. In other words, an environment utterly alien to our solar system. Gradually, consensus began to crystallize not around a single mechanism but around a deeper truth. 3 Atlas had been born in a chemical context entirely foreign to ours. Its building blocks were shaped by a star that lived fast and died early, one whose ashes carried a metallic imbalance unlike anything in our records. The comet wasn't defying science, it was extending it into territory our laboratories could barely imagine. At conferences, the tone shifted from disbelief to reverence. One researcher compared the discovery to finding a Rosetta Stone written in the elements themselves. Another called it a galactic accent, a reminder that even atoms can speak with different dialects depending on the star that forged them. As the nickel lines continued to blaze from the comet's tail, a poetic image spread through the community. They began to describe 3 Atlas as a forge adrift, a tiny remnant of a star that once burned hotter and brighter than the sun, now whispering its chemistry across space. The comet had become both artifact and author, rewriting our understanding one spectral line at a time. Every orbit carries a story, and the path of 3 Atlas tells one that stretches back before the birth of the sun itself. Its trajectory through space, the exact angle of its hyperbolic curve, its speed, its inclination relative to the galactic plane, all pointed toward an ancient origin. When astronomers traced that path backward through simulation, following it across millions of years of motion through the Milky Way's gravitational tides, they found something astonishing. This comet might have come from the thick disk of the galaxy, a region populated by stars so old they remember the galaxy's youth. The Milky Way is not uniform. It's layered like sediment, each band of stars a different generation in the grand chronology of cosmic evolution. The thin disk where our sun lives is young, bright, and full of heavy elements. The thick disk, by contrast, is ancient, home to stars that formed when the universe was poorer in metals. Those suns shine with a subdued amber light, their planets, if any, forged in scarcity. It is within this antique population that 3 Atlas may have been born. To understand what that means, imagine rewinding time 7 billion years. The galaxy was smaller, denser, more chaotic. Supernovas erupted in waves, seeding the void with just enough oxygen, carbon, and nitrogen to build the first complex molecules. Iron and nickel were still rare, unevenly distributed like patchy paint across the galactic canvas. Somewhere in that tumult, a star formed less metallic than our sun, older by eons, and around it a disk of dust began to swirl. Within that disk, pieces of ice and rock collided, fused and froze. One of them would one day become 3 Atlas. Because of that heritage, the comet's chemistry is like a fossilized dialect of the galaxy's early language. Its imbalance between nickel and iron mirrors the elemental scarcity of its birth era. Its surplus of carbon dioxide hints at a warmer protoplanetary zone closer to its star, where water might have been scarce but carbon-based ice is abundant. Every molecule that evaporates from its surface today carries isotopic clues about that long-lost system, a time capsule of an ancient star's environment. When astronomers realized this, the discovery shifted from strange to sacred. 3 Atlas wasn't just another interstellar visitor. It was a survivor from an epoch older than Earth. It had traveled for billions of years, through radiation storms and stellar winds, through the void between spiral arms, until at last it crossed paths with us. To study it was to touch history, cosmic history measured not in centuries but in ages. Spectroscopic data strengthened the case. The ratios of oxygen to carbon, the distribution of minor isotopes, the faint spectral redshift in certain emission lines, all were consistent with material forged in low metallicity conditions. In simple terms, this comet was ancient, possibly older than the Sun by 3 or 4 billion years. Its nucleus had never melted, never broken, never been reshaped by a planetary system's gravity. It was pristine, a messenger from a time when the periodic table had fewer entries. That realization carried an almost spiritual weight. For the first time, scientists were not just looking at an object from another star, they were seeing a piece of the galaxy's childhood preserved in ice. When data from the Gaia Space Telescope confirmed the orbital modeling, the room went quiet. Someone whispered half in disbelief, "We're watching an elder of the cosmos breathe." In the months that followed, new models suggested how such a relic could survive so long. Ejected from its parent system by the gravitational chaos of young giant planets, it drifted into interstellar space where temperatures fell close to absolute zero. At those extremes, chemistry stopped. Molecules that would normally react or decay simply froze locked in stasis. 3 Atlas slept for eons, until it wandered into the sun's faint pull and began to wake. Its awakening was a cosmic event not just for astronomy but for imagination. Every gas molecule escaping its surface was like the sigh of a ghost from a time before Earth existed. Scientists compared its spectral fingerprint to that of ancient metal-poor stars and found harmony, as if the comet were humming the same song those suns still sing in their dim light. And as the data poured in, one truth crystallized: 3 Atlas might be the oldest physical traveler humanity has ever observed. A frozen envoy from a time when the Milky Way was still learning how to build planets. Somewhere deep within that icy core lies the oldest light never meant to shine again. But now, as sunlight caresses it for the first time in billions of years, it glows softly, stubbornly, carrying the memory of a star that burned out before our world began. While professional astronomers chased 3 Atlas across the heavens with billion-dollar instruments, another group, anonymous, unpaid, and armed only with laptops, was making discoveries of its own. They called themselves citizen scientists. Some sat in small apartments, others in backyard observatories, their screens glowing through the night. They were part of a global movement that had become the quiet heartbeat of modern astronomy. One of their favorite projects was a network called Radio at Home. It invited volunteers to scan radio telescope images for patterns no algorithm could easily recognize. Most of what they saw was noise, faint arcs, static, the occasional bright dot. But in early spring of the year, 2025, a volunteer noticed something that stopped them cold. 2 overlapping rings of radio emission, vast and ghostly, floating in the sky like halos of invisible fire. The discovery became known as RAJ 1334, the largest odd radio circle ever identified. These orcs, as scientists call them, are huge structures hundreds of thousands of light years across, visible only at radio frequencies. No one knows what they are. Theories range from shock waves fired from supermassive black holes to the dying breaths of galaxies themselves. Yet it wasn't a research team that spotted this new one. It was a hobbyist scrolling through data on a home computer. News of the find spread quickly through forums and chat rooms. Soon more volunteers began reporting faint circular shapes in other regions of the sky. Some of those turned out to be noise, but several were confirmed real by professional telescopes. In less than 6 months, citizen scientists had doubled the known population of odd radio circles. Astronomers were stunned and quietly grateful. Machines could process data faster, but humans still saw what code could not: the unexpected. As this was happening, public interest in 3 Atlas surged again. Amateur observers began capturing their own images of the comet through modest telescopes, stacking exposures for hours until a dim green glow appeared against the stars. They posted their results online, a faint orb exhaling in the dark, its motion perceptible night by night. In comments beneath the photos, people began to speculate, half in jest, half in awe, that maybe the same citizen eyes finding radio ghosts might one day spot the next interstellar wanderer before the professionals did. And they weren't entirely wrong. Many of the most significant astronomical events in recent years had begun with an amateur's curiosity. A retired teacher in Japan had discovered supernovae by scanning the same patch of sky every evening. An engineer in Britain had detected an unusual variable star using a modest backyard setup. Even some near-Earth asteroids had first been flagged by volunteers comparing image sequences online. These were not flukes. They were proof of a new paradigm. The data, too vast for any institution to handle, could now be shared, parsed, and explored by the collective curiosity of thousands. The cosmos had become a collaboration. Still, not everyone welcomed this democratization. Within academic circles, a quiet tension brewed. False positives, instrumental glitches, mistaken for discoveries consumed time and resources. And for every disciplined observer, there were many who saw patterns in noise, faces in static, alien signals in harmless interference. To professionals, citizen science was both gift and gamble, a flood of enthusiasm that needed filters. But even skeptics couldn't deny what was happening. The same human instinct that once made early skywatchers map constellations was now guiding people through petabytes of digital starlight. It was evolution, not replacement. Algorithms could find what they were trained to see, humans could find what they didn't yet understand. In late April, when the discovery of RAJ 1334 was officially confirmed, one volunteer wrote a line that went viral. "We're not just watching the universe, we're helping it reveal itself." The phrase resonated across scientific conferences, quoted even by researchers who had once doubted the project. It captured something profound, that wonder still matters, that participation itself can be an act of discovery. And perhaps that is why the stories of 3 Atlas and the citizen astronomers became intertwined. Both were outsiders in their own way, a comet forged beyond the sun's reach, and a community of skywatchers forging science beyond the Academy's walls. Each challenged the boundaries of who gets to witness mystery, reminding the world that exploration isn't owned, it's shared. As more data poured in from orbiting telescopes, ground arrays, and citizen servers, the same theme kept emerging. Anomalies thrive at the edges. Whether in a comet's alien chemistry or a volunteer's quiet discovery, the universe reveals its secrets to those willing to notice the strange. For every triumph of citizen science, there is an echo of tension in the background, a quiet tug-of-war between professional caution and public enthusiasm. When 3 Atlas and the new radio anomalies became trending topics, the lines between expertise and excitement blurred. In research institutes and online forums alike, a single question pulsed: who gets to decide what counts as discovery? In the old world of astronomy, discovery was a sacred process. You gathered data and submitted your findings to peer review and waited for months of scrutiny. Only then could a new object, a new phenomenon, earn its place in the official catalogues of the cosmos. But the digital age had upended that rhythm. Volunteers now found things overnight, posted them online before any journal could act, and sometimes saw their names go viral before the professionals had even opened their telescopes. That speed thrilled the public, but unsettled the institutions. Astronomers had seen what unverified claims could do: false alarms of alien signals, viral misinterpretations of data, entire conspiracy theories born from misread pixels. It wasn't arrogance that made them cautious, it was experience. Verification mattered because truth in science must outlast the news cycle. Still, there was beauty in the chaos. Across continents, new collaborations began to bloom. Researchers from the Royal Astronomical Society and data volunteers from open-source observatories started forming hybrid teams. Professionals handled calibration, error analysis, and confirmation. Amateurs handled the endless hours of scanning, pattern recognition, and preliminary alerts. Slowly, a system took shape that merged rigor with reach. But not everyone wanted cooperation. On social media, a fringe of self-proclaimed truth seekers began to hijack the narrative. To them, every unexplained signal hinted at government secrecy or alien interference. They accused observatories of censorship when findings were delayed for review. Screenshots of telescope data taken out of context circulated like digital myths. 3 Atlas, with its green glow and impossible chemistry, became the centerpiece of speculation. Was it a natural comet, or something else entirely? The scientists sighed, exhausted. They understood the psychology behind it. When the universe speaks in riddles, humans crave meaning. A comet acting alive felt too poetic to remain just physics. It demanded a story, and where science offered uncertainty, imagination rushed in. To counter misinformation, some astronomers turned to public engagement. They began live streams, answered questions in plain language, and shared real data openly. Their tone shifted from defensive to inviting, "Come see what we see, let's solve this together." To their surprise, it worked. The same networks that once amplified rumors now began debunking them. Citizen scientists became mediators between wonder and reality, translating jargon into fascination. In one memorable exchange, a volunteer analyst noticed a faint fluctuation in 3 Atlas's brightness curve and speculated that it might signal a temporary outburst. Instead of dismissing the claim, professionals investigated. Within days, they confirmed that the comet had indeed flared its green light, intensifying briefly before returning to normal. A collaboration born of curiosity had produced real science. This moment changed everything. The tone online shifted from competition to cooperation. Amateurs began using standardized reporting templates. Research groups created portals where observations could be verified in near real time. The gap between the two worlds started to close. Yet the friction never vanished entirely. Every few weeks, new rumors surfaced about hidden data, about secret missions following the comet, about things NASA won't say. It was the same human pattern repeating itself. A reminder that knowledge and myth often orbit the same star. But amidst that noise, a quieter truth was emerging. Science wasn't losing control, it was evolving. The era of guarded observation was giving way to one of shared vigilance. 3 Atlas had become more than an object of study. It had become a bridge between experts and dreamers, between precision and passion, between the measured language of data and the electric pulse of wonder. The comet's light didn't belong to anyone, it belonged to everyone looking up. And maybe that was the real discovery hiding behind the science, that knowledge grows best when no one claims it as their own. In the chill nights of October, the sky above Earth staged a coincidence that would have seemed scripted if it were not so utterly random. Mercury gleamed in the western twilight, bright and high, while Ceres, the queen of the asteroid belt, stood in opposition, shining directly opposite the Sunday. Between them, 3 Atlas burned its emerald flame, streaming gases from an impossible distance. It was a scene so perfect that the human mind refused to believe it was chance. Social media overflowed with charts and overlays showing lines connecting Mercury, Ceres, and the comet, forming geometric patterns that some insisted were messages, alignments, or cosmic warnings. The internet baptized it the October Triad. Astronomers rolled their eyes but understood the allure. Our species is built to see patterns. Once that instinct kept us alive, spotting animal tracks, predicting weather, reading the seasons. Now it manifests in subtler ways, turning the cold geometry of space into myth. Journalists began asking scientists whether the alignment might have triggered 3 Atlas's outgassing. The experts explained patiently, no. Mercury's gravity was negligible compared to the Sun's, and Ceres was far too small to have any measurable influence. The comet's behavior was internal, driven by chemistry and light, not celestial choreography. But explanations couldn't compete with enchantment. People love a story that fits neatly, a universe that whispers purpose. The mind resists randomness. It aches for narrative. And so, in countless threads and videos, the coincidence blossomed into meaning. Some claimed the trio symbolized awakening Mercury for thought, Ceres for rebirth, the comet for revelation. Others saw omens of disaster, the prelude to an upheaval yet unnamed. In truth, coincidences are inevitable in a sky so full of motion. Thousands of bodies dance through the solar system, and now and then their paths appear to align. Statistically, it would be stranger if such moments didn't happen. Yet every generation rediscovers this pattern-finding reflex and wraps it in its own mythology. Historians of science pointed to a famous example. More than a century earlier, when Halley's Comet returned in the year 1910, newspapers had terrified readers by announcing that its tail contained cyanogen gas, a poison. As Earth passed through the tail, people sealed their windows, wore masks, and bought anti-comet pills. Nothing happened, of course. But the pattern of fear-repeated coincidence breeds narrative. Narrative breeds belief. Now 3 Atlas was the new stage for an old drama. The pattern seekers saw symmetry, the scientists saw statistics, and between them stood wonder, an emotion shared by both sides, though expressed in different languages. Psychologists watching the frenzy coined a term, the coincidence effect. It described the way unrelated cosmic events, when occurring close in time, amplify each other's perceived significance. The mind links them like beads on a thread, turning happenstance into design. It's an act of meaning-making that feels spiritual even when it's mistaken. What fascinated the sociologists wasn't the misinformation, but the yearning beneath it. The same impulse that misreads data also drives art, faith, and science itself. The refusal to accept that the universe is silent. Whether through religion or research, humans keep asking the same question: what does it mean? As the October nights passed, Mercury sank lower, Ceres dimmed, and 3 Atlas moved on. The alignment dissolved, leaving behind only screenshots and speculation. Yet for millions who had looked up, something lingered, a shared sense of participation, of being part of a celestial conversation. In that sense, the coincidence had done something rare and precious. It reminded people to look skyward, to remember that our tiny world is surrounded by motion and mystery. For all the misunderstandings, there was beauty in that. And perhaps that's the paradox at the heart of astronomy. The same instinct that invents false patterns also fuels genuine discovery. The universe doesn't arrange alignments for our benefit, but we arrange meaning around them anyway. It's how we stay curious, how we stay human. On the 8th day of October in the year 2025, the Texas desert should have echoed with the sound of fire and triumph. Blue Origin's New Shepard rocket lifted off under a clear sky, carrying 6 passengers to the edge of space, a brief suborbital flight barely 11 minutes from launch to landing. By all official accounts, it was flawless. Yet within days, whispers began to spread. Did it really happen at all? The story began like any other press release. A launch window, a manifest, a cheerful statement from the company. Cameras tracked the rocket as it pierced the thin blue horizon, arcing toward the boundary, known as the Kármán line, 100 kilometers above Earth. Their passengers would experience weightlessness for a few fleeting minutes before descending beneath parachutes. Routine familiar, almost mundane in an era when space tourism had become a luxury brand. But what followed was anything but routine. When journalists searched for footage of the event, they found almost nothing. No cabin videos, no live-streamed reactions, no triumphant clips of passengers floating and laughing. The media coverage was curiously sparse. One article from a major network, a few tweets from space reporters, and then silence. In the vacuum left by that silence, speculation expanded like gas in a chamber. Online forums dissected every frame of the official broadcast. Some users claimed the footage looked too clean, as if reused from an earlier flight. Others swore that the desert landing site in the video didn't match satellite imagery from that date. A handful even proposed that the flight had been simulated. The recording delayed the crew non-existent. The spark became a wildfire, the vanishing launch, they called it. Commentators connected it to everything from corporate secrecy to cosmic conspiracy. One thread claimed the mysterious 6th passenger, a wealthy donor who requested anonymity, wasn't a tourist at all, but a government payload. Another insisted the flight's silence hid an incident the company didn't want to admit. Within a week, what began as curiosity had curdled into suspicion. To scientists studying 3 Atlas, the timing was almost poetic. The comet's impossible behavior had already stirred global debate about truth, perception, and the limits of knowledge. Now, a space mission only a few hundred kilometers above Earth was triggering the same questions. What counts as real when evidence feels incomplete? The parallels grew eerie. Just as the comet's green glow defied explanation, the launch's absence of noise felt unnatural. People didn't believe what they couldn't see. In an age flooded with information, silence itself became suspect. Sociologists later described it as an inverted transparency crisis. When technology makes every event public by default, anything less than total visibility feels like deception. The crowd demands proof of reality, and if proof doesn't arrive fast enough, imagination fills the gap. Blue Origin eventually released additional details, telemetry logs, crew interviews, images from the capsule's onboard cameras, but by then the narrative had taken root. Every clarification was reinterpreted as cover-up, every correction as manipulation. Debunking only deepened the intrigue. In online discussions, the launch's uncertainty merged with the comet's mystery. A viral post joked that the missing footage was swallowed by 3 Atlas on its way past Jupiter. The joke traveled faster than the truth. Soon memes blurred into belief. And yet, underneath the noise, something genuine stirred. People were not just doubting corporations, they were questioning their own trust in perception. What does it mean to witness something indirectly, to rely on pixels, edits, and statements from unseen experts? The more humanity depends on technology to observe the universe, the more fragile observation itself begins to feel. That's why the story endured. It wasn't about a rocket or a company, it was about our evolving relationship with evidence. The same tools that let us watch 3 Atlas from billions of kilometers away also leave us vulnerable to disbelief here on Earth. In a strange way, the vanishing launch became a reflection of the comet itself, a reminder that mystery doesn't just live out there in the stars, it lives here too, in the gaps between what we see and what we choose to believe. Whenever the universe surprises us, our first instinct is to see ourselves in the reflection. Every comet, every strange signal, every unexplained flash in the night sky becomes a kind of mirror, showing not only the cosmos but the shape of our own imagination. 3 Atlas was no exception. Its luminous tail and impossible chemistry didn't just bend science, it bent psychology. Humans have always turned to the heavens to understand themselves. When ancient people saw comets, they saw omens, the death of kings, the wrath of gods, the promise of change. In the 21st century, our tools have changed, but our reflex hasn't. Now we see the same patterns through telescopes instead of temples. The language has evolved from prophecy to probability, yet the awe remains the same. With 3 Atlas, that awe returned in full force. The comet's outgassing felt alive, its green glow seemed intelligent. For some, it symbolized resilience, a frozen relic from another world refusing to remain silent. For others, it stirred an older longing, the hope that something out there might be aware of us. Every mystery becomes a question of belonging, and every question of belonging becomes a mirror of loneliness. Psychologists studying the wave of public fascination called this cosmic projection. They noted how the patterns of interpretation, fear, wonder, suspicion, replayed the same dynamics that appear in religion, art, and even politics. People saw in 3 Atlas whatever confirmed their inner worldview. To the rational, it was data. To the poetic, it was revelation. To the fearful, it was a warning. The phenomenon echoed earlier episodes in astronomy, when the star now known as Tabby's star began dimming unpredictably years before scientists proposed dust clouds or debris fields. But the public imagined something else, a Dyson sphere, a megastructure built by an advanced civilization. The idea spread not because it was likely, but because it was beautiful. It offered meaning wrapped in mystery order, disguised as enigma. And that is the power of the unknown. When science reaches its edge, imagination rushes in to fill the silence. Oumuamua was another example. A shapeless visitor that some believed was a probe, others a rock, and still others a metaphor for how little we understand about the universe. Each interpretation said more about the observer than the object. In that sense, 3 Atlas was less a comet and more a stage. On it, humanity rehearsed its eternal roles: the skeptic, the dreamer, the believer, the cynic. One looked through data and saw physics. Another looked through the same data and saw purpose. Neither was entirely wrong. Science begins with skepticism, but is sustained by wonder. A philosopher writing for a science journal put it best. Every anomaly is a mirror, and every mirror reflects a question. What kind of beings need the universe to be stranger than it is? It's not just curiosity that drives us toward mystery, it's yearning. The need for meaning is as powerful as gravity. So, When people stared at images of the comet, they weren't just studying an object in space, they were studying themselves. The pale light of 3 Atlas fell onto their retinas, but the real illumination happened inward. They saw hope disguised as chemistry, purpose disguised as physics, and connection disguised as coincidence. Perhaps that's why we chase anomalies so fiercely. The unexplained reminds us that knowledge is still alive, that we haven't mapped it all, that mystery still has room to breathe. Even if 3 Atlas turns out to be nothing more than a peculiar comet obeying strange but natural laws, its role as a mirror remains sacred. It showed us for a moment that the universe is still capable of surprising us, and that we are still capable of being surprised. Imagine the galaxy not as a wilderness of stars, but as a vast library, each shelf a spiral arm, each book a world, each wandering object a letter written by physics itself. That is how astronomers began to think of interstellar visitors like 3 Atlas. They were not just rocks and ice, they were messages, samples of foreign chemistry drifting from one stellar civilization of matter to another. The metaphor wasn't just poetic, it was precise. Every interstellar comet is a record of conditions that once existed around another star. Its temperature, its metallicity, the radiation that bathed it, the balance of carbon, nitrogen, and oxygen. When such an object crosses our sky, it's as though a page from a different cosmic chapter flutters into our hands. We read it in light, then watch it drift away. So far, astronomers had 3 confirmed entries in this galactic anthology. The first, Oumuamua, the silent messenger, dry tumbling and enigmatically propelled. The second, Borisov, the faithful echo, behaving like a comet from home but carrying an accent of extra carbon. The third, 3 Atlas, the storyteller alive with volatile breath spilling water and nickel and cyanide in defiance of every law we thought we knew. 3 travelers, 3 dialects of creation. If so few objects could show such diversity, then the galaxy must be a dictionary of difference. It suggested that planetary systems are not siblings but strangers, each molded by its own sun's temperament. To scientists, that realization was thrilling. For centuries, we assumed our solar system was typical, its chemistry a standard model for all others. But the data from these cosmic visitors whispered otherwise. Our way might be rare. Perhaps most planetary nurseries produce comets unlike ours, made of exotic ices bound by unknown bonds, carrying elements in combinations we've never imagined. The galactic average might be alien to us. And yet what unites them is motion. Each comet, no matter how strange, travels through the same gravitational web, passing from one stellar neighborhood to another, ferrying material across light years. In that exchange lies the seed of something profound: panspermia, the possibility that the building blocks of life travel between stars aboard these frozen couriers. Whether or not 3 Atlas carries life itself is irrelevant. What matters is that it carries information, the ingredients of life, the signatures of ancient stars, the ratios of elements that tell us how varied and generous creation can be. The universe doesn't write books with words, it writes with isotopes, with spectra, with motion. Each comet is a chapter, each trajectory a sentence, and we are only beginning to learn how to read. This idea transformed the mood of astronomy. What once felt like isolation, the vast silence between stars, began to feel like connection. Space was no longer empty but full of correspondence. The cosmos was exchanging mail, and our telescopes were the mailboxes. Every interstellar visitor was proof that matter travels, that history drifts, that knowledge migrates. It also reframed a deeper question. If life ever began elsewhere, could comets like these have carried its chemistry to us? The notion was old but newly urgent. Scientists imagined a young Earth bombarded by countless icy bodies, each delivering amino acids, hydrocarbons, and water, the ingredients of potential. If that process is common, then life may not be unique. It may be the galaxy's most persistent export. When 3 Atlas began releasing cyanide, an organic precursor, essential in prebiotic chemistry, the excitement deepened, not because it proved life, but because it showed potential written across the void. A single molecule glowing green in the dark became a cosmic signature, saying, "I come from elsewhere, but I speak your chemistry." In the decades ahead, as new telescopes rise and better surveys scan the skies, astronomers expect to find dozens, maybe hundreds of such interstellar objects. Each will carry a different story: a water-rich wanderer, a methane glacier, a dust-cloaked relic of a dead star. Together, they will fill the shelves of the galactic library we've only just opened. And perhaps someday, when our instruments are swift enough, we'll catch one before it leaves. We'll land on its surface, read its atoms like lines of text, and finally answer the question. All these cosmic books are hinting at how many ways can the universe write the word life. Among all the strange signals 3 Atlas sent back through its light, none stirred more fascination than its metallic song, the unending blaze of nickel without iron. To the public it was a curiosity, to astronomers it was revelation, to astrophysicists it was data written in the alphabet of stars. They began to call it the nickel code, a chemical cipher left by the galaxy's past. Every element tells a story about where it was born. Hydrogen and helium came from the Big Bang, carbon, oxygen and nitrogen from ordinary stars. But nickel and iron, those twin metals, are the handwriting of catastrophe. They form only when stars die in supernova explosions so violent that matter itself becomes art. The exact ratio between the two acts like a signature identifying the kind of death that forged them. Most stars, including our sun's ancestors, leave behind balanced debris, iron and nickel, in near equal abundance. But 3 Atlas carried an imbalance so extreme that it pointed to something unusual, a parent star that had not died in the standard way. The data hinted at a specific origin, a Type 1 supernova, the thermonuclear death of a white dwarf that consumed its companion. Such explosions are bright enough to be seen across galaxies, and strange enough to leave fingerprints like this. The comet's composition was a survivor's testimony. Somewhere billions of years ago, a small star had reached its end. It grew unstable, devoured its partner and detonated. In that flash, nickel flooded the surrounding gas cloud while iron lagged behind. Later that same cloud cooled, condensed and formed the protoplanetary disk that birthed 3 Atlas. What we now watched as shimmering vapor in its tail was in truth the ashes of a supernova. That realization carried a poetic symmetry, a comet shedding the remnants of a star's death while circling another star's life. It turned chemistry into genealogy, each atom a descendant tracing its lineage through cosmic ancestry. When telescopes measured the isotopic ratios, the match was clear. 3 Atlas bore the isotopic pattern of nickel-58, the form produced in nuclear furnaces that burned briefly, violently, and long ago. The discovery reframed how astronomers think about interstellar objects. They were no longer random debris but curated relics, each preserving the memory of its parent system's birth and death. The nickel emissions weren't a mystery anymore, they were history made visible. But then, as happens whenever the universe hands us a pattern, imagination began to stretch it further. Some speculated that if comets carry the metallic records of supernovas, they might also carry records of technology artifacts from civilizations lost to time encoded in isotope ratios, waiting for someone to notice. The idea was fantastical, but it ignited something electric in the imagination. For centuries, humanity had searched the skies for alien messages in radio waves or mathematical constants. What if the messages were chemical, instead written not by intention, but by existence? Of course, the sober answer was simpler. Nature, through its blind artistry, had already written the most eloquent code imaginable. Nickel without iron was a story of creation through destruction of balance, shattered and remade. It was the universe reminding us that even in death, stars compose. To study 3 Atlas was to decode that composition. By tracing its elements backward, astronomers could reconstruct a piece of the galaxy's autobiography, a chapter where ancient suns erupted and seeded the void with their bones. And in that sense, the comet was not merely an object, but an archive, a drifting microcosm of the Milky Way's long memory. When one scientist summarized the finding at a conference, her words silenced the room. "We're not just seeing what a comet is made of," she said. "We're seeing what the universe remembers." In the green shimmer of its tail, 3 Atlas carried both the violence of its birth and the peace of its present, a duality that mirrored our own creatures, born of fire, learning to read the quiet light of ancient metals. It began, as many great speculations do, with a single question murmured in a late-night conference hall: what if the anomaly wasn't natural at all? The suggestion was not meant as sensationalism. It was rather an exercise in humility. When nature refuses to behave, scientists sometimes ask whether their assumptions about natural are wide enough. 3 Atlas, with its perfect imbalance of metals, its green glow, its almost intentional rhythm of outgassing, invited that kind of dangerous curiosity. What if someone proposed the comet's odd chemistry wasn't the fingerprint of a dead star, but the byproduct of intelligence? What if its nickel-rich makeup resembled not a relic of astrophysics, but of engineering industrial waste slag, or even residue from large-scale metal extraction billions of years ago? The room had gone still. No one truly believed it, but no one dismissed it either. It was too poetic to ignore a comet, as cosmic litter drifting evidence of a civilization so old that only its chemistry remained. The thought experiment spread quietly through forums and research notes. Imagine they said an advanced species mining asteroids for iron and leaving behind nickel-rich residue. Imagine fragments of that debris coalescing into icy rubble ejected from their home system, crossing the galaxy for eons, until one piece arrived here, our 3 Atlas. To be clear, there was no evidence for such a claim. The spectral data fit natural explanations far better. But the scenario raised a profound philosophical point. How would we even recognize technology when stripped of design, intention, and context? A shovel buried for 1,000,000 years becomes a stone. A spaceship weathered by light years becomes a comet. The difference between artifact and asteroid might be thinner than we think. Carl Sagan once wrote that extraordinary claims require extraordinary evidence. Yet 3 Atlas reminded us that evidence itself can age. What if time erases the fingerprints of design so completely that what remains is indistinguishable from nature? If a civilization died before our species learned to walk upright, its ruins would no longer look like ruins, they would look like 3 Atlas. A few researchers published speculative essays exploring what an archaeology of physics might look like. How do you detect intention in matter when all patterns appear random? They proposed chemical asymmetries, isotope anomalies, or geometric concentrations as possible clues. Nothing conclusive, only the invitation to stay open. Public fascination, of course, ran faster than caution. Headlines screamed alien comet before the papers had even been peer-reviewed. Scientists once again found themselves trapped between curiosity and control, fascinated by the question, afraid of the hysteria. But buried beneath the noise was something beautiful. Even in speculation, humanity was doing what it does best, imagining connection. The idea of artificial ashes wasn't about aliens, it was about continuity. It was a way of saying that the universe might be full of stories older than memory, written not in words, but in elements. If intelligence once existed elsewhere, its relics would not come to us as monuments, they would come as dust. They would drift into our skies, disguised as comets, as pebbles, as whispers of ratios no natural process could easily explain. The universe, generous and cruel, would erase everything but the trace. And maybe that's what 3 Atlas really teaches us, not that it is artificial, but that the line between invention and nature is less distinct than we imagine. After all, human beings themselves are stardust, organized into self-awareness. Our cities, our machines, our questions, these too are the cosmos learning to engineer itself. When scientists finally set aside the thought experiment, their notebooks filled with a quiet reverence. They wrote equations with steadier hands, knowing that they had glimpsed something beyond data, but the possibility that the boundary between life and lifelessness, art and accident, creator and creation, is not a wall but a mirror. In that mirror, 3 Atlas looked back at us not as a message but as a reminder. Even if it is nothing more than a comet, it proves that the universe can sculpt wonder precise enough to mimic intention. And perhaps that is miracle enough. Once the noise of speculation faded, the scientists returned to what they did best, measuring, cataloguing, connecting. The comet had inspired wild ideas, yes, but it had also awakened a practical dream to map the unseen history of the galaxy through the chemistry of wandering worlds. They began calling themselves, half-jokingly, the cartographers of the void. It started with a simple premise. Every interstellar object, comet, asteroid, or fragment carries the elemental signature of the star system it came from. Trace those signatures, and you could draw invisible borders across the Milky Way territories of composition islands of chemistry. Each could tell the story of a region's formation, its star's death, its planet's possibilities. To make such a map, data had to be gathered and compared across decades. Spectral readings from Oumuamua, Borisov, and 3 Atlas were aligned in databases alongside stellar surveys from the Gaia mission. The goal was to match trajectories and isotopic patterns to find which regions of the galaxy produced which flavors of matter. The early results astonished even the skeptics. The first pattern emerged in nickel itself. The unique imbalance found in 3 Atlas wasn't random. It matched ratios seen in certain old stars of the thick disk, the very stellar population suspected to be its birthplace. Another clue came from the oxygen isotopes in its water vapor, slightly heavier than those in Earth's oceans. The shift suggested formation under cooler, lower pressure conditions, further supporting its ancient origin. As the data grew, a kind of stellar genealogy began to take shape. Comets became like family names tracing descent lines across the galaxy. The cartographers spoke of chemical constellations, groups of interstellar objects sharing similar ratios, hinting that they were siblings ejected from the same ancestral nursery. For the first time, chemistry and orbital mechanics were being woven together into a single narrative map of cosmic heritage. Visualizations transformed this abstract data into wonder. On digital displays, the galaxy unfolded not as a spiral of light, but as a mosaic of hues, each color representing a distinct chemical lineage. Patches rich in oxygen glowed blue iron-heavy zones, burned red nickel-dominant regions shimmered green. Somewhere in that glowing tapestry, 3 Atlas traced a thin emerald thread linking our solar system to an older, quieter corner of the Milky Way. The implications were profound. If enough interstellar travelers could be catalogued, humanity might one day reconstruct the chemical evolution of the entire galaxy. An atlas, not of geography, but of ancestry. Every future comet discovered would be another waypoint in that story, another pin in the star map of matter's migration. And yet, beneath the excitement, there lingered awe. The scientists realized they were effectively performing archaeology on a galactic scale. Each object they tracked was a time capsule from billions of years ago, carrying unspoken testimony of stars that no longer exist. They weren't just studying space, they were studying memory. One astronomer compared the process to listening for echoes in an ancient cathedral. "The stones don't speak," she said, "but if you listen carefully, you can hear the shape of every song ever sung inside." 3 Atlas was one such echo, its nickel light, the faint reverberation of a long-extinguished choir of stars. To the public, these findings reignited fascination with the idea that the universe itself might be conscious, not alive in the biological sense, but aware through memory. The Milky Way, they said, remembers. Every comet, every atom, every photon is part of its recollection. In truth, the cartographers of the void knew better. The galaxy doesn't remember. We do. We are the remembering part of it, the nervous system of the stars, the mechanism by which matter looks back at its own origin. And in that revelation, the work took on a quiet holiness. Data became devotion. To map the galaxy wasn't just to study creation, it was to participate in it, to add one more line to the cosmic autobiography that 3 Atlas had begun to write in vapor and light. For every interstellar object humanity has spotted, astronomers know there must be countless others passing unseen. The galaxy is full of travelers we'll never meet, worlds adrift in the dark, whispering past our sun without leaving even a glint in our telescopes. They call this invisible population the unseen fleet. The idea is not poetic fantasy, it's mathematics. If 3 known visitors, Oumuamua, Borisov, and 3 Atlas, were detected in just a few short years, of modern observation logic dictates that thousands more must have slipped by unnoticed in the centuries before telescopes grew sharp, enough to catch them. Statistically, there should be several wandering through the solar system at any given moment, too faint, too fast, or too far for us to see. Most of them are small fragments of ancient collisions, dust-sheathed icebergs, pebbles ejected from dying stars. A few might be the size of mountains. Some may drift for billions of years between suns, carrying with them the frozen chemistry of alien skies. The thought alone transforms the void from emptiness into traffic. Astronomers have begun to model this hidden armada. By simulating stellar formation and planetary ejection, they estimate that every star on average expels millions of such fragments during its lifetime. Multiply that by the hundreds of billions of stars in the Milky Way, and the numbers become staggering, an ocean of debris so vast that even light years seem crowded. Yet only a handful ever wander close enough for us to notice. When the Vera Rubin Observatory begins its sky survey, its ultra-wide mirror will scan the heavens every few nights, photographing the entire visible sky again and again. Scientists predict it could discover one interstellar visitor every month, maybe more. With each new detection, the unseen fleet will grow a little more visible. The knowledge changes how we think about cosmic solitude. Space no longer feels like an empty desert, but a drifting migration of worlds, each on its own exile, each carrying chemistry older than the Sunday. Some may bear traces of life's ingredients: water, organic molecules, even amino acids locked in ice. Others may be sterile, sculpted only by radiation and cold, but all are records, data points in a story written across billions of years. 3E Atlas reminded us of that. Its bizarre composition was not just anomaly, it was probability manifest. If even one interstellar comet can behave so differently from our own, imagine the diversity of those we've never seen. Somewhere out there might float a methane comet glowing red, or a nitrogen glacier humming in radio frequencies, or a shard of planetary crust carrying fossilized air from a world that no longer exists. For the cartographers of the void, this unseen fleet is both challenge and promise. Each discovery adds another pixel to the galactic picture, yet also deepens the mystery of what remains unobserved. It's like studying the ocean through the bubbles that reach the surface. You learn the currents indirectly, never the full shape below. But perhaps that's fitting. The universe is not meant to be fully witnessed, it's meant to be pursued. The unseen fleet is the cosmos's way of reminding us that wonder multiplies faster than knowledge. Some night, as you look up, remember, even when the sky appears empty, 1,000 silent travelers are crossing above you. They carry the dust of other suns, the metals of vanished stars, and the same atoms that now form your blood and bones. You are part of their fleet too, just slower bound to a star that hasn't yet let you go. Long before 3 Atlas began to fade from view, another idea took hold among astronomers, a dream so audacious it bordered on obsession. If the universe kept sending these visitors across our sky, why not chase one down? Why not meet an interstellar traveler in person while it was still close enough to touch? They called the concept interstellar intercept. It was equal parts engineering challenge and existential dare. To catch an object like 3 Atlas required speed beyond anything humanity had yet achieved. These comets moved at tens of kilometers per second, faster than any probe humanity had ever launched. By the time most were discovered, they were already fleeing the solar system, fading into distance before a mission could even be planned. But that didn't stop the dreaming. At NASA's Innovation Labs, engineers began sketching rapid response probes. Spacecraft kept on standby, fueled, powered, waiting. The moment a new interstellar object was detected, the mission would launch within weeks, slingshotting around planets for speed, then intercepting the traveler before it escaped. Some designs use solar sails, others imagine nuclear engines or ion propulsion systems that could burn for years. The European Space Agency drafted its own vision, Project Lyra, a proposal to chase after the first interstellar visitor, Oumuamua. Though that ship was long gone, the idea proved contagious. It wasn't just about one object, it was about readiness. Humanity needed a cosmic emergency response team, scientists who could act at the speed of discovery. The logic was simple. Every interstellar visitor is a once-in-a-lifetime opportunity to study matter from another star system. If even one could be intercepted, drilled, or sampled, it would change science forever. A single grain of alien dust could reveal isotope ratios, molecular recipes, even biological precursors that Earth had never seen. To hold that material in human hands would be like holding a piece of another solar system's soul. 3 Atlas made the dream feel closer. Its discovery, early in its trajectory, gave scientists time to imagine what an interception might look like, what instruments to bring, what questions to ask. Could they drill through its crust before solar heating melted it? Could they trap its vapor in cold canisters and return it home? The answers were uncertain, but the ambition was electric. For once, the question of why needed no justification. Humanity has always chased the unreachable, the horizon, the atom, the heartbeat of the stars. The difference now was that the stars were sending emissaries to meet us halfway. As plans matured, simulations multiplied. Supercomputers modeled trajectories for the next century, predicting where and when the next interstellar visitor might appear. The models suggested that within 10 years, with new sky surveys and improved algorithms, we could expect a steady stream of candidates, one every few months. Each one would be another invitation. The mission planners knew it would not be easy. Building a spacecraft capable of reacting fast enough, accelerating hard enough, and surviving deep space cold demanded both money and miracles. But as one engineer said during a conference in Pasadena, "We built machines to leave the planet. Now it's time to build one to leave the solar system by choice, not by chance." In that sentence, a century of longing crystallized. From Galileo's telescope to the Voyager probes, every step of astronomy had been about looking farther. Now, for the first time, humanity dared to reach across the gulf and touch something that didn't belong to us. Even if such a mission succeeded, it might take decades to reach its quarry. The scientists who designed it might not live to see the data return. Yet they planned anyway, driven by the same impulse that had guided all explorers to leave behind questions sharper than the ones they inherited. In this way, 3 Atlas became both muse and challenge. It showed what waited out there, the unexpected, the unrepeatable, the sublime, and so, even as it dwindled into the dark, it left a commandment written in light: chase me. For most of scientific history, discovery moved at a pace slow enough for certainty. Astronomers could spend years studying a single object, refining theories, adjusting models. But now, in the era of automation and infinite data, the sky itself had become overwhelming. Every night, telescopes generated more information than any human could read in a lifetime. And hidden within that flood were anomalies, thousands of them waiting to be understood or misunderstood. 3 Atlas was no longer a solitary mystery. It had become part of a wider pattern, one that defined 21st century astronomy. Too much data, too many surprises, too little time. Every survey brought something that didn't fit. A radio pulse from a distant galaxy lasting less than a blink, a star dimming in irregular rhythms, a dark void where theory said light should be. Each anomaly was both treasure and trap. This flood of the unexplained created a paradox. The more the universe revealed, the less sense it seemed to make. In the 20th century, astronomers had believed they were closing the gaps, filling in the map of existence. By the middle of the 21st, they realized the gaps were multiplying. Each answer opened a dozen new questions. The public watching this avalanche of discovery swung between awe and exhaustion. Headlines screamed, "New cosmic mystery baffles scientists," so often that it became routine. People stopped asking if something strange had been found and started asking what's next. Mystery itself had become normal. Scientists called this the anomaly cascade. The term described a self-reinforcing loop. Better technology produced more discoveries, which produced more confusion, which demanded even better technology. Telescopes caught things too fleeting for theory to keep up with. Data processing algorithms flagged phenomena that no one had words for. Astronomers joked that they were now janitors in the universe's laboratory, forever cleaning up the mess of the unknown. Yet in that chaos, something profound was happening. Science was rediscovering humility. For a brief moment in human history, it had seemed that the cosmos could be reduced to equations. Gravity explained orbits, quantum mechanics explained atoms, evolution explained life. But anomalies, these small rebellions of reality, reminded us that understanding is not conquest, it's conversation. And 3 Atlas was a perfect participant in that conversation. Its contradictions were elegant, its defiance consistent. It wasn't chaos, it was complexity, whispering that the universe still had depths we hadn't sounded. It taught scientists to look not just for what fits, but for what doesn't, because truth hides in disobedience. The flood of anomalies also changed how research was shared. Once data stayed locked behind institutional gates, now it was broadcast in real time, inviting anyone with curiosity and internet access to explore. The borders between expert and enthusiast blurred further. Somewhere in the torrent of public data, a teenager might already be staring at the first frame of the next cosmic revolution. Philosophers of science began calling this the golden age of ignorance. not ignorance as failure, but as invitation, the recognition that not knowing is fertile ground. To admit confusion is to make room for discovery. The scientists who studied 3E Atlas embodied that principle. They spoke openly about uncertainty, about wonder, about the thrill of questions that refused to resolve. And in doing so, they changed the culture of astronomy itself. The field stopped chasing final answers and began embracing the permanent storm of curiosity. The sky was no longer a solved equation. It was a living manuscript forever rewriting itself. As 3E Atlas moved farther from the sun, fading into the outer dark, its legacy remained. It had not rewritten physics. It had rewritten expectation. It reminded humanity that the greatest discoveries often begin, not with knowledge, but with the courage to say we don't know yet. When the universe became too strange for comprehension, humanity did what it always does. It turned confusion into narrative. Every mystery was folded into a story, and every story became a belief. The age of belief was not an age of superstition, but of saturation. Information moved too fast for consensus, and in that blur, truth fractured into fragments of conviction. 3E Atlas was a perfect mirror for that fragmentation. For some, it was a triumph of science evidence that chemistry itself could surprise us. For others, it was a symbol of cosmic intention, proof that the universe still whispered secrets to those willing to listen. And for a small but fervent few, it became something darker, an omen, an artificial beacon, a sign that humanity was being watched. The Comet story splintered into 1,000 versions across digital landscapes. Each community built its own mythology, sculpting the facts into meaning. Some called it the Green Messenger, linking its eerie color to ancient prophecies about stars that breathe. Others claimed its nickel signature matched the isotopic ratios of certain spacecraft alloys, a coincidence, but one too delicious for skepticism to survive. The more scientists tried to clarify, the more the myths multiplied. Sociologists studying these movements coined a new term, belief recursion. It described how modern myths evolve, not by invention, but by reflection, stories that consume themselves, feeding on attention until they become self-sustaining. Every attempt to disprove a claim only deepened the conviction of those who held it. The comet, once a piece of frozen rock, had become a psychological engine. But underneath the noise, there was something tender at work. The same minds that spun conspiracy also spun poetry. Artists painted 3E Atlas as a living eye. Musicians wrote symphonies timed to its orbital rhythm. Philosophers compared its unpredictable behavior to consciousness itself, an emergent phenomenon arising from chaos. Even the skeptics who rolled their eyes at such ideas couldn't deny the beauty of what was happening. The comet had become collective imagination in motion. The astronomers who first discovered it watched this with conflicting emotions. They wanted accuracy, not allegory. Yet they also understood that wonder was not the enemy of truth, it was its gateway. Humanity needs stories to care, and caring precedes understanding. In a world flooded with facts, stories give shape to feeling. One scientist interviewed years later said it best: "People didn't fall in love with our data, they fell in love with what it meant to them, and maybe that's fine. Maybe meaning is the first form of measurement." In classrooms, teachers began using 3E Atlas to teach both astronomy and media literacy. Students studied how the same object could generate science, art, and myth simultaneously. They learned that reality doesn't lose value when dressed in imagination, it becomes richer. The danger only comes when imagination refuses correction. And slowly, a new equilibrium formed. Scientists accepted that public interpretation was part of discovery's afterlife. Myths like comets have trajectories, they flare, bright fade and leave traces. What mattered was ensuring that somewhere beneath the embellishments, the core remained a comet from another star, shedding water and nickel where physics said it shouldn't. In that way, 3E Atlas became a case study in how belief evolves in the information age. It showed that data alone is never enough. People seek belonging through wonder, and if the same story can inspire both superstition and science, perhaps that duality is not a flaw, it's the mark of a species still learning to live with mystery. Because even when stories eat themselves, something survives the hunger to know. In the wake of 3E Atlas, the scientific community faced an unexpected question. How much wonder can data contain before it stops being science and starts becoming story? For centuries, objectivity had been the golden rule. Scientists were trained to remove emotion, to speak in numbers, to let the universe reveal itself without the interference of awe. But 3 Atlas had blurred that boundary. Its green shimmer, its alien chemistry, its refusal to obey equations, these weren't just anomalies, they were invitations. They reminded even the most disciplined minds that discovery is emotional first and analytical second. The spark that sends someone chasing comets or building telescopes is not logic, it's longing. So began what some called the reconciliation of wonder. Young scientists stopped pretending detachment was purity. In lectures and conferences, they spoke of beauty, alongside precision of meaning, alongside measurement. Papers began to include sections titled Implications for Curiosity, Bridging Data with Philosophy. For the first time in decades, science felt lyrical again. And in that shift, 3 Atlas became a touchstone, a story about keeping both eyes open, one for evidence, one for awe. Universities used it as a teaching model, showing students how to communicate discoveries without killing their poetry. Emotion is not error, one professor said. It's the instrument we use to tune attention. In parallel, communicators learned a new language, neither the dry jargon of academia nor the fevered exaggeration of viral media, but something in between. They described the comet not as proof of aliens or magic, but as proof of mystery's endurance. Because in truth, mystery is what science feeds on. Each answer consumes itself. Each question gives birth to more. Public outreach changed too. Instead of merely correcting misconceptions, astronomers began inviting people into the uncertainty. When asked on live broadcasts whether 3 Atlas was alive, one scientist smiled and said, "Not in any way we define life, but maybe it teaches us to define life better." That kind of response didn't dismiss imagination. It redirected it toward inquiry. The balance wasn't easy. Some critics argued that celebrating mystery diluted rigor. Others feared that blending art with science blurred credibility. Yet as years passed, the fusion proved resilient. The most successful research projects became those that inspired as well as explained. Funding followed fascination. Fascination followed openness. By embracing wonder, science regained something it had quietly lost: intimacy. The sense that the universe wasn't just a subject to be studied, but a relationship to be maintained. When people watched the green tail of 3 Atlas fade into the dark, they didn't just think about molecules or light. They felt kinship, an ancient, wordless connection to everything that drifts, glows, and vanishes. This was the human key of science, the melody that threads through every equation and every telescope lens. The recognition that we study the universe not because it needs us, but because we need it to remind us of scale, of humility, of possibility. Years later, a physicist wrote in her memoir, 3 Atlas reminded us that to be rational without wonder is blindness by another name. Her words became a kind of creed whispered in labs and observatories worldwide. And so, science evolved, not away from emotion, but through it. The line between explanation and reverence blurred until both stood together, balanced like sunlight and shadow. The comet was gone, by then a fading point in the outer dark, but its legacy glowed in the hearts of those who learned from it that the pursuit of truth need not exile. Beauty, and that awe when held with discipline, is the purest form of understanding. Light is the oldest storyteller. Before there were words or instruments, it carried the first messages across the void whispers of birth and death, of burning stars and frozen dust. Every color, every flicker, every shimmer of a comet's tail is a sentence in that endless language. To read light is to listen to the universe remembering itself. 3 Atlas spoke fluently in that dialect. Through its spectrum, astronomers learned everything they could not touch: what it was made of, how fast it moved, what kind of chemistry lived beneath its surface. When its green glow appeared, no one needed to see the comet directly. The light itself told the story. But as instruments grew sharper, a new realization dawned. Light doesn't just describe the cosmos, it frames it. How we capture it, how we color it, how we interpret it shapes what we believe. The same light that birthed theories of creation also birthed myths of gods. And so, when 3 Atlas flared across the sky, it illuminated not only space but the human need to translate radiance into meaning. Journalists turned spectra into headlines, artists turned data into color, filmmakers rendered simulations that made invisible physics look like miracles. Every transformation added something and lost something, an interpretation layered over a signal. In that layering, science and storytelling began to blur. Scientists, for their part, realized that communication itself had become an instrument. A discovery unseen by the public risks being forgotten. A discovery misunderstood risks being misused. To preserve truth, they had to master metaphor. They learned that the only way to protect knowledge from distortion was to make it beautiful enough that people wanted to understand it correctly. Outreach campaigns framed 3 Atlas not as an anomaly, but as an ambassador. Documentaries followed its journey from detection to disappearance, pairing equations with orchestras showing that numbers could sing. The phrase "the comet that breathes" became shorthand for curiosity itself, a poetic doorway into physics. In classrooms, students studied its spectrum as literature. The bright nickel lines became punctuation marks, the cyanide glow, a tone of tension, the water emissions, a chorus of change. For the first time, many realized that science isn't a barrier to beauty, it's a deeper form of listening. That shift rippled outward. The same techniques used to decode 3 Atlas were applied to other cosmic puzzles, the radio bursts, the dimming stars, the echoes of black holes. Each phenomenon became both a data set and a narrative, an act of translation between the language of photons and the language of feeling. And perhaps that was the comet's greatest legacy. It reminded humanity that how we tell the unknown is as important as what we discover. The light itself may be objective, but the stories we build around it shape the way future generations will see the universe. When the last images of 3 Atlas faded into the archives, the data didn't vanish. It was reborn as art, as education, as memory. In that transformation, light completed its journey from the core of a forgotten star through the cold of interstellar space into the lenses of our telescopes, and finally into the hearts of those who tried to understand it. Somewhere that light is still traveling, its photons stretching across time, carrying with them the same question that began it all. What else is out there, waiting to be read? The deeper astronomers looked into the story of 3 Atlas, the more they discovered that truth itself was not a single beam of light, but a spectrum layered, overlapping, sometimes contradictory. Data, it turned out, could cast shadows. When the comet first appeared, instruments from around the world recorded its every shimmer, but those instruments didn't all agree. Some measured slightly higher temperatures, others found inconsistencies in water ratios or metal lines. Even the comet's brightness seemed to fluctuate depending on the filter used. Scientists called it instrumental parallax, the distortion born not from the object, but from the observer. At first, those mismatched readings were frustrating, but over time they revealed something subtler. Every data set, no matter how precise, carries the fingerprint of perspective. Even machines have biases, detectors tuned to certain wavelengths, algorithms optimized for certain assumptions. What we call truth is really a mosaic of approximations that overlap like shadows on a wall. The comet became a classroom in epistemology. Teams compared their datasets line by line, trying to reconcile the differences. Some blamed calibration drift, others proposed that 3 Atlas itself might be variable, its jets shifting, its chemistry changing faster than expected. The answer, as usual, was both. The universe was complex, and our instruments imperfect. Philosophers of science saw a metaphor in this dance of data. Objectivity, one wrote, is not the absence of perspective, it's the conversation between perspectives. By combining imperfect views, we inch closer to understanding, though we never reach perfection. The lesson resonated far beyond astronomy. Climate scientists, geneticists, even historians recognize the same pattern in their work. The overlapping of partial truths, each shaped by method and medium. 3 Atlas became a case study in humility, a reminder that reality doesn't simplify itself for our comfort. In documentaries, this theme found a haunting visual expression. Editors layered telescope images over one another, infrared, ultraviolet, optical, radio. Each revealed a different face of the same object. Viewed together, the comet shimmered like a ghost seen through multiple dreams. The composite was neither illusion nor correction, it was truth seen from all sides at once. But the public, used to clarity, sometimes resisted. People wanted a single answer, not a cloud of probabilities. Is it alive or not, they asked. Is the nickel natural or artificial? What's the real explanation? Scientists struggled to convey that real and complete are not synonyms. Reality, they said, is fractal. The closer you look, the more versions you find. Over time, this idea seeped into culture. The word uncertainty stopped being an insult and became a virtue. In classrooms, students learned that error bars weren't signs of weakness, they were signs of honesty. In art galleries, installations projected overlapping spectra of 3A Atlas onto walls, showing that even beauty deepens when it admits ambiguity. And within the scientific community, the comet left a quieter legacy. It taught researchers to see disagreement not as division, but as dialogue. Competing models became collaborative maps, contradictions became coordinates. In the end, 3 Atlas offered not one story but many. Each dataset was a thread in a vast tapestry, and only by viewing them together could humanity glimpse the full image, still incomplete, still evolving, but richer for its contradictions. Maybe that's what truth has always been, not a destination but an interference pattern, not a single light, but the shadows that dance when many lights overlap. When 3 Atlas crossed the inner edge of the solar system, its color deepened from silver to green. Through telescopes, the glow seemed almost alive, a living pulse against the dark. Astronomers explained that the hue came from cyanide molecules and nickel emissions excited by sunlight. But for everyone watching from Earth, the comet's radiance felt like something more, a signal, a visitation, a moving mirror, reflecting our own restless need to search. People across continents gathered to see it. In deserts, mountains, and city rooftops, they turned their eyes skyward and shared the same silence. Live streams became vigils. Observation turned into meditation. For the first time in years, the internet's noise gave way to awe. Millions stared at the same streak of light and thought the same thought: we are small and that is beautiful. Philosophers called 3 Atlas the Green Witness, not because it observed us, but because it made us observe ourselves. Its light touched the same atmosphere that holds our breath, the same oceans that gave us life. Watching it burn through emptiness, people saw a metaphor for their own existence, fragile bodies illuminated briefly by an impossible fire. The comet reminded humanity of something easily forgotten, that knowledge and meaning are not opposites. Science explained the chemistry of its glow, but it was wonder that made people look up in the first place. The two forces, analysis and awe, fed each other, creating a rare harmony of intellect and emotion. Even scientists bound by precision admitted to feeling reverence. In research logs, their technical notes slipped into poetry. One wrote, "We are staring at the breath of another star." Another confessed, "It feels wrong to measure something that looks back." Around the world, artists painted 3 Atlas in shifting shades of jade and emerald. Musicians composed symphonies timed to its orbit. Spiritual leaders spoke of it in sermons as a symbol of renewal, an ancient traveler reminding us that motion itself is survival. The comet became both fact and fable, a bridge between language and light. But what made it unforgettable was its impermanence. Night after night, its brightness waned. The tail stretched thinner. The green faded to white, and soon it was gone, swallowed by the same dark from which it came. Observatories archived terabytes of data, but the feeling of its presence lingered longer than the images. In that fading, people recognized a pattern that echoed their own lives. Everything burns briefly. Everything leaves traces. The comet's arc across the heavens became a lesson in mortality that comforted instead of frightening. To see something so ancient move with such grace, only to vanish, was to understand the quiet dignity of impermanence. Poets called it a teacher without language. Children seeing it disappear asked their parents if it would ever come back. The honest answer, no, carried its own kind of holiness. Not all beauty is meant to return. Some only pass through to remind us that we are part of the same cosmic rhythm, born, bright, gone. Years later, when astronomers replayed the final images, the green shimmer looked almost like memory itself, visible proof that even fleeting things can alter the course of thought. The comet had come and gone, but the questions it left behind were eternal. What else moves unseen? What else waits to be witnessed? And so 3E Atlas became not just a scientific event, but a human one. Its trajectory marked more than a path through space. It marked a moment when an entire species stopped scrolling, looked up, and remembered what it feels like to be alive beneath a sky that still has mysteries left to offer. When 3 Atlas finally slipped beyond the reach of even the largest telescopes, what remained was motion itself, pure, unending, unsentimental motion. It had entered the solar system in silence, left in silence, and carried with it everything we had projected upon it: questions, hope, fear, and wonder. In its retreat, humanity was left with an insight that was both humbling and liberating. The universe, it seemed, does not speak in permanence. It speaks in movement. From the beginning, the comet's story was about defiance, an object behaving where it should not, burning when it should freeze. But by the end, it had revealed something simpler: that movement is meaning. A comet exists only because it travels. Its identity is not in the ice it carries, but in the path it draws. When it stops moving, it ceases to be a comet at all. That truth, small and cosmic, at once began to ripple through other disciplines. Biologists saw it mirrored in evolution, life as a constant process of adaptation, never at rest. Economists compared it to systems of exchange energy flowing through societies. Philosophers revived ancient ideas: Heraclitus's river, the Buddhist wheel of becoming, each echoing the same wisdom that 3 Atlas had demonstrated in light. Everything changes, therefore everything is alive in its own way. The comet had been a teacher of kinetics, not metaphysics. Yet in tracing its arc, humanity learned that meaning, like matter, must move. Knowledge stagnates when held too tightly. Understanding requires orbit, revisiting, revising, returning again from new angles. The scientists who followed 3 Atlas found themselves changed not just professionally but personally. They spoke of it as a living mentor, one that taught through vanishing. In a paper published years later, an astronomer wrote, 3 Atlas reminded us that motion is memory in disguise. Every trajectory carries the echo of its origin and the promise of its destination. The quote spread across campuses and observatories, painted on lab walls and mission badges. It became a quiet mantra for a generation of researchers who had grown weary of certainty. For ordinary people, the message was simpler. The comet's passage became a metaphor for resilience. It had crossed the interstellar void for billions of years, surviving radiation collisions and absolute cold, only to blaze once when chance brought it near the sunday. That brief moment of visibility was its purpose, fulfilled not to last forever, but to remind the universe that endurance can be silent. Writers turned the event into parable. In novels and films, 3 Atlas became the traveler who never stops, the messenger who never lands. Artists sculpted spirals of glass and metal to represent its orbit, each twist a symbol of persistence without arrival. The idea resonated because it felt human. We too move through darkness, shaped by forces we barely understand, burning briefly before vanishing into memory. And so, motion became the comet's final gift. It reframed how humanity thought about progress, not as a straight line toward mastery, but as an orbit of renewal. Each generation learns, forgets, and learns again, tracing new ellipses around old questions. 3 Atlas simply reminded us that even in departure there is connection. Even in loss there is momentum. When astronomers plotted its final course out past Neptune, beyond the heliopause, into the endless dark, they marked the coordinates in silence. Somewhere out there, far beyond human reach, the comet still drifts, still breathes, faintly through sublimation, still writes its invisible line across eternity, and perhaps that is enough. For a species obsessed with arrival, 3 Atlas offered a gentler philosophy that meaning is not found at the end of the journey, but in the act of continuing. Long after 3 Atlas disappeared into the outer dark, its data remained streams of light, curves, spectra, and chemical readings stored in digital archives scattered across Earth. To the scientists who had studied it, those numbers became something sacred, a letter from the universe written in the grammar of physics, and like all letters, it begged to be read, not just for information but for meaning. One astronomer described the comet as a cosmic correspondent, a messenger that didn't speak but recorded. In its vapor and metal lay the echoes of a star long gone, the environment that shaped it, and the quiet story of how galaxies recycle themselves. Through 3 Atlas, the stars had sent us news of their own history. That realization reframed the role of astronomy itself. Observing the universe was no longer passive, it was correspondence, an exchange between awareness and creation. Every telescope was a listening post, every photon a postcard. The stars were not silent, they were speaking in persistence. The data from 3 Atlas contained patterns that deepened this metaphor. Its isotopic ratios aligned almost perfectly with those predicted for material formed in the galaxy's thick disk, confirming that its origin predated the Sunday. It carried the chemical accent of an older cosmos, one less rich in metals but abundant in resilience. Each molecule of water it shed had been frozen since before Earth existed, waiting patiently to rejoin starlight. In classrooms, students analyzed those molecules as if deciphering an ancient text. They learned that science is a kind of translation, a process of turning the inhuman into something we can hear. Just as linguists resurrect dead languages from fragments of clay tablets, astronomers reconstruct stellar histories from fragments of light. But this correspondence wasn't one way. Humanity too was now sending messages back to the stars. Every radio signal, every spacecraft, every photon reflected off our world was a reply. Voyager's golden record, the pulses of our radar, the faint radio hum of our cities. All these were letters written in noise, drifting outward at the speed of curiosity. The universe had spoken first, now we were answering. In that exchange, people began to see themselves as part of the galactic dialogue. The comet had arrived uninvited, yet it reminded us that existence itself is conversation. The same processes that forged 3 Atlas forged our atoms. The same cosmic chemistry lives in our blood. We are not observers, we are participants, temporary sentences in an unending correspondence of matter. The metaphor caught fire in culture. Artists painted 3 Atlas as a mail carrier of starlight scattering luminous envelopes through the void. Writers described its path as a signature, a flourish left by the galaxy's own hand. The phrase cosmic correspondence entered everyday speech, used to describe moments when humans felt the vastness of belonging, watching auroras, holding meteorites, or simply looking up at the night sky. Even religion found resonance in the image. Theologians called it a modern psalm, a hymn not to gods but to the persistence of communication. The stars had written first, humanity merely learned to read. Years later, when scientists revisited the data, they found new subtleties, minor spectral lines previously overlooked, hints of compounds that expanded the chemical diversity even further. 3 Atlas was still speaking, its archived light yielding new sentences long after its departure. And maybe that is what makes correspondence eternal. The message keeps changing each time it's reread. Like starlight, meaning doesn't fade, it redshifts. Out there, the comet continues its flight, its nickel shining faintly as it leaves the heliosphere. Perhaps someday, another civilization will catch its trail and study it as we did. Perhaps they'll read the same message in a different way. That possibility is the most beautiful kind of humility. The recognition that knowledge, like language, never truly belongs to one species alone. When 3 Atlas disappeared into the black, it didn't mark an ending. It marked the beginning of a new kind of science. For the first time, astronomers were not only studying the past written in starlight, but preparing to meet the future halfway. The comet had taught them to anticipate, to look forward, not just in time, but in imagination. Astronomy has always been an act of looking backward. Every photon we see is a relic, every galaxy a memory of itself. But 3 Atlas altered that rhythm. Its discovery had come early enough for the world to watch its story unfold in real time, proving that the universe doesn't only reveal what was, it reveals what's coming if we learn how to listen soon enough. That realization sparked a quiet revolution. Researchers began to speak of predictive observation, a philosophy that treated the cosmos as a living system, with habits, rhythms, and potential futures waiting to be mapped. Rather than waiting for anomalies to arrive, They would forecast them, anticipating new comets, new radio bursts, new cosmic visitors before the instruments even caught them. At the center of this effort were algorithms trained on everything 3 Atlas had taught. They learned its timing, its spectral quirks, its erratic behavior. These digital oracles began to comb through data faster than any human could, searching for echoes, patterns that whispered another one is coming. The idea wasn't to replace curiosity, but to amplify it. Machines would catch the faintest tremors of discovery. Humans would give them meaning. Within a decade, early prototypes succeeded. A small cluster of observatories using these new systems predicted a faint interstellar body months before its arrival. When telescopes confirmed it, the sense of triumph was quiet but immense. Humanity had not just discovered a wanderer, it had expected one. The sky for the first time felt less like chaos and more like conversation. This new predictive science rippled beyond astronomy. Geologists began applying similar models to planetary activity. Biologists used them to track the evolution of microbial life in extreme environments, suspecting parallels to what might exist on icy moons. Even artists took notice, creating generative works inspired by the principle that beauty could be forecast like weather. But perhaps the most profound impact was psychological. Anticipation changed how people related to the cosmos. The universe no longer felt like an indifferent spectacle. It felt participatory. Humanity was no longer a spectator of creation, but a correspondent preparing for replies yet to arrive. Still, not everyone welcomed this shift. Some feared that predictive science risked taming the very mystery that made discovery magical. If we could foresee every comet, every anomaly would one to survive. Others argued that anticipation and surprise were not enemies but partners. The more we expect, the more miraculous the unexpected becomes. In that debate, 3 Atlas remained a reference point. It was the proof that even perfect prediction cannot erase astonishment. We had known it would brighten, and still it astonished us. We had measured its trajectory, and still it felt alive. No algorithm could model the feeling of watching it breathe. That was the lesson scientists carried forward. Anticipation properly held is not control, it is reverence in advance. It is the readiness to be amazed. And so, the new generation of astronomers grew up not under the old motto, seek and find, but under a new one inspired by the comet's legacy, listen and await. The sky had become a dialogue, and every discovery now felt like a response to a question we had not yet thought to ask. Somewhere beyond the edge of sight, 3 Atlas continued its journey, an echo of the past carrying the promise of the future. Its fading tail was both reminder and prophecy that every answer the universe gives contains within it the next question. Years after 3 Atlas had vanished beyond the heliopause, its influence remained like a faint afterglow. The comet itself was gone, but the world it passed through had changed. It left behind an orbit of memory, a path not through space but through thought. For scientists, that orbit lived in data terabytes of spectra, trajectories and analyses that continued to yield discoveries long after the comet's departure. Each new interpretation felt like a return passed through its trail, a perihelion of remembrance where curiosity warmed again. In research papers, references to 3 Atlas became shorthand for the improbable, the boundary-breaking, the yet-to-be-explained. But for the rest of humanity, its orbit was more intimate. People still spoke of where they were when they saw it, the night they stayed awake to catch a glimpse of that impossible green. Couples proposed under its light. Children drew it in school notebooks. Poets described it as a breath from elsewhere. Even those who never saw it felt its echo in headlines, art, and conversation. The comet had become a shared metaphor for impermanence, connection, and curiosity itself. Sociologists studying the aftermath noticed a subtle but lasting effect. In the years following its appearance, public interest in astronomy and planetary science surged. Donations to space programs increased. Enrollment in astrophysics courses doubled. The world, for a brief and precious window, remembered how to look up. That cultural momentum didn't fade with the comet's light. It transformed into infrastructure, new telescopes, faster observatories, and global collaboration networks built on the dream that 3 Atlas had reignited. The Atlas generation, as journalists called it, grew up seeing science not as abstraction but as belonging. They had watched the universe respond to human attention. and that changed how they defined participation in the cosmos. Artists kept that conversation alive in their own medium. Galleries displayed installations of glowing vapor, suspended nickel dust, and soundscapes made from spectral frequencies. In one exhibition, a slow pulse of green light crossed a dark room every 11 minutes, the time it took the comet to rotate. Visitors stood in silence, feeling as if the universe itself were breathing again. Writers compared 3 Atlas to a teacher who never spoke but changed everything. It didn't give us answers, one essayist wrote. It gave us better questions. The phrase became a mantra in both science and philosophy. Universities printed it on banners. Students scrawled it on lab doors. But perhaps the most poignant memory lived in those who had felt its presence directly, the people who had looked up and realized that distance could still inspire intimacy. For them, the comet had become a symbol of hope, proof that even across billions of kilometers, something foreign could touch their hearts with light. And in a way that hope was justified, 3 Atlas may have left, but its fragments lingered. Dust from its tail drifting through the solar wind eventually intersected Earth's orbit. Invisible particles fell through our atmosphere, burning out in moments too small for eyes to see. Scientists estimated that thousands of microscopic grains from the comet now rest on Earth's surface, embedded in polar ice caught in mountaintop snow, mingled with the air we breathe. In that quiet truth lies poetry. We carry pieces of it with us. The boundaries between the comet and humanity dissolved atom by atom. What was once alien became intimate, folded into the planet's skin, into the story of our sky. The orbit of memory, then, is not circular. It spirals outward forward into every mind still wondering what else drifts unseen. The comet may never return, but its trail continues to loop through us, invisible, yet gravitational, pulling thought toward wonder, again and again. The story of 3 Atlas ends where it began, in silence. No explosion, no epilogue, no final blaze. Just the faint hum of a world turning beneath an indifferent sky, and somewhere beyond the edge of the sun's warmth, a small body of ice continuing its slow and endless journey. But endings, like comets, are only visible transitions. What we call disappearance is often only distance. Out there, 3 Atlas still exists, its nucleus spinning quietly, its metals cooling in the dark. Every few millennia, it will pass another star and scatter another breath of vapor, a reminder that motion and memory are the same thing at different speeds. Here on Earth, the noise it once created of theories, art, fear, fascination has softened into reflection. Humanity no longer looks for it in the sky, but listens for it in the quiet moments between discoveries. Because 3A Atlas was never just a comet, it was a question disguised as light. What if the universe is not trying to be understood, but to be heard? That thought has changed everything. Scientists now speak less of control and more of communion. They describe their work as listening, not dissecting. Telescopes are ears as much as eyes. Data are echoes waiting to be interpreted. The universe, they say, doesn't hide its secrets. It sings them softly beneath the static. In that philosophy, 3 Atlas is the first note of a longer melody. It taught us to recognize wonder not as interruption but as rhythm. Its green shimmer was only one chord in a vast composition that spans billions of years and trillions of stars. The melody continues whether we watch or not, but when we choose to listen, we join the song. For ordinary people, the lesson was simpler still: to look up, to pause in the rush of daily gravity and remember that we orbit too, that our lives are part of a movement so large that even silence has a direction. Parents still tell their children about the comet that breathed, and those children in turn will tell theirs. The story will keep circling like its subject, gathering new meaning each time it returns. Somewhere in the data archives, the last transmission of 3 Atlas, a faint ultraviolet spectrum recorded by a satellite, still plays on repeat. To most, it's a static hum, meaningless. But if you listen long enough, something in it feels alive. A pulse, a breath, a rhythm that might be coincidence or might be the universe whispering the same truth through every form it takes. Everything moves, everything changes, nothing is lost. And perhaps that is the quiet return, not the comet coming back to us, but us returning to the awareness it left behind, the realization that we too are temporary sparks of motion, carrying our own brief glow through the infinite dark. As the centuries pass, 3E Atlas will drift beyond the stars. We know its dust mingling with the next generation of worlds. One day, atoms that once belonged to it may become part of a new planet, a new sky, maybe even a new kind of life looking up and wondering where it came from. If that day ever comes and those distant mines find traces of nickel and water in their air, they may name the source differently, but they will be reading the same sentence we once did, a line from the universe's oldest poem: "We are all made of motion."